is
like
unique.
the analogy for someone who hasn't done this is, but plays an instrument. You play scales and arpeggios on a piano. That's like learning the mathematics, but that's not the same thing as playing music. That
Exactly.
the theory construction and the synthesis comes in.
And that's the qualitative aspect. Yes.
But you can play as many scales as you like and not be a good musician. It's all, you know, making
Yes.
it.
And you are playing the scales of mathematics to reveal the beauty in neural networks and how the brain works, if I may continue the metaphor.
The harmonies of our mind.
Exactly.
That
Wow. Wow. Hello, everyone, and welcome to Mindplex, the Singularity Net community podcast, where we dive into the minds of the world's greatest thinkers and innovators. Today, we inaugurate our 2025 conversations with no other than the Einstein of the mind, as we are honored to have Stephen Grossberg, Professor Emeritus at Boston University, a pioneer in neuroscience, psychology, and artificial intelligence, join us. Often referred to as the father of artificial intelligence, the Newton and Einstein of the mind, Professor Grossberg has spent nearly 7 decades transforming our understanding of how the brain learns, adapts, and creates a mind. With 18 books, over 560 peer reviewed research articles, 7 patents, and countless accolades, he has left an indelible mark on science. His work has provided fundamental insights into artificial intelligence, mental health, and human cognition, and he continues to inspire innovations that align technology with human values. Stephen Grossberg is a cognitive scientist, neuroscientist, mathematician, biomedical engineer, and a trailblazer in neuromorphic technology. He is the creator of adaptive resonance theory, which is currently the most advanced cognitive and neural theory of how our brains learn to attend, recognize, and predict objects and events in a changing world that is filled with unexpected events. Today, we will explore his magnum opus, Conscious Mind, Resonant Brain, how each brain makes a mind. This is his last book, and we will discuss how his discoveries reveal the brain's inherent bias towards good behavior and universal values. We will also delve into the implications of his work for building ethical AI towards the singularity. So I'm going to start by welcoming Professor Grossberg to the podcast. Welcome, Professor Grossberg. Now I have to say, because I'm so proud of that I know you and I met you, although in passing, when I was a postdoc, and I will not say how many decades ago,
but where
and
was it?
it was in '94.
But where? Maybe it'll.
It was in the US at the International Congress of Neural Networks, which
Oh,
actually you
yeah.
founded. Yes. And so as I was doing, continuing my PhD, which was in fuzzy logic, and of course, we're delving into neural networks as well and neurofuzzy, I attended that with my postdoc supervisor, which was Lotfi Zadeh. So both of you and Lotfi
Well,
had
he was
keynotes.
a dear friend. I love that man.
Yes, and he loved you, and I know that he really appreciated your titanic work and contributions enormously. And I know that you have received the Lotfi Zadeh Award,
I
kind
did
of.
actually.
Yes, so
But
that's amazing. For me to more or
very
less be a part of that,
good.
it's so amazing. Your work is motivated by a desire to look inward into the human cognition and understand how we function, how the mind originates in the brain, of course, how we learn, what causes mental disorders, and so on and so forth. And this drive to develop technologies in alignment with biology is part of what distinguished you from most scientists. Because there is little concern about such matters in our education system and in general in society, including in the development of technology. where deep learning is an example since the focus is on engineering efficient computational models while disregarding the biological plausibility. And this drive led you as a freshman in psychology at 17, well, which a sign of genius already, to introduce neural networks. And I will disclose that was in 1957, and I disclose now a lot about your age.
Well,
Uh,
I was 85 on New Year's Eve.
wow.
And I'm glad to have made it to 85.
And we are also so grateful because, as far as I know, and we may get that towards the end of the podcast, you are working on another book, but we will get there later. So, for now, I'd like to start by asking you what brought you at such an early age to make such a crucial discovery?
Well, of course, it was a surprise to me too, because it was in 1957, and all I was doing was taking introductory psychology as a college freshman at Dartmouth College. And ultimately, I think I introduced the field of neural networks then because I was inspired by a lot of psychological data about how humans learn. And that's what I'd spent my whole life doing, learning. And these psychological data led me to derive my first neural models of how our brains make our minds and the basic equations that are still used today in one variant or another in all biological neural networks. And that's why I think, as you mentioned, I'm sometimes called the father of AI because if you think of AI as being neural networks, both biological and artificial, that's really what I started. Uh, Now, I was led from mind to brain for a basic fact. Brain evolution must achieve behavioral success for evolution to succeed. And without the brain mechanisms, one can't understand psychological functions, including learning, which I was very interested in. But without the psychological functions, brain mechanisms have no behavioral meaning. And so I really felt the need to somehow understand both levels. And we now know that interactions within and across several brain regions are often needed to generate these psychological functions because psychological behaviors are emergent properties or interactive properties of millions of brain cells interacting across multiple brain regions. And no purely experimental approach can fully understand emergent properties. For this, models, theories are essential. And in order to derive such models over the years, I developed a modeling method and cycle. And let me say why I think that's so important. In brief, it's because we're never done understanding the mind. So, because brain evolution needs to achieve behavioral success, the modeling method starts by analyzing scores or even hundreds of psychological experiments, since these are the experiments that describe behavior. And so I had to read a ton of psychology until I could develop a deep experimental intuition into the meaning of the data. And in so doing, the method enabled me to discover design principles that underlie large psychological databases. Now, that's an art. No one tells you how to do it. You have to live in the data until your intuition lets you see that simple principles underlie lots of seemingly different data, which in the first place, no one groups for you. You have to use your intuition and develop your intuition and group the data all at once. And having understood some of the design principles, then my task was to describe them as the minimal models that embody those principles and use those models to explain a lot more psychological data that would be used to describe them. Now, I didn't know any neuroscience when I did this. It was a surprise to me that the models looked like neural networks that were able to explain and predict a lot of neural data. That was an explanatory leap that I wasn't anticipating. And that's why this work might be called biological neural network models. They're models of how the brain generates behavioral properties. But no one derivation can explain a whole brain. We're never done. And so after doing such a derivation and explaining what I could with it, which was more data than went into the hypotheses behind the derivation, I could see the boundary between what I could explain and the unknown. And the shape of that boundary always suggested new hypotheses that led me to derive a more comprehensive model that could explain more data without undermining the explanations I already gave and maybe even refining them. So there was this method and cycle to discover new design principles and mechanisms, and always with the idea that you'll get a richer model that included the earlier one, but maybe more sophisticated. So, for example, as of 2008, I think, I was able to introduce what's often called the Laminart model, and it describes how and why we have lamina neocortical circuits. That is to say, layers, often 6 basic layers with some sublamina and perceptual and cognitive neocortex, and how identified cells in these lamina circuits could explain a lot of perceptual and cognitive data, which in itself is, something you wouldn't expect. And having mentioned Laminart, maybe I should.
I would like just to, first of all, underline from
Yeah,
what you said
yeah.
the rigor that is implied in your work, because there's so much speculation in our day and age when it comes to how the brain works, consciousness, and so on and so forth. And it's really pure speculation, as you said, also. So your work, because you are actually a mathematician, right? Which and a psychologist, mathematician, everything, and
Well,
therefore you
I
have the
started
tools.
as a psychologist, and I was forced to, to study a lot of mathematics
Yes.
in order to express my psychological intuitions.
But you have a degree in mathematics. I mean,
Yeah,
it's forced, not forced. You got it. Yes, you are.
but you have to have enough technique to fluently explain your intuitive ideas as rigorous models. And I maybe went overboard. I took 90 credits of advanced mathematics at Stanford as a graduate.
Yes.
But then I wrote my PhD thesis on how neural networks that learn at the Rockefeller University.
Which
So
involves a lot of mathematics. So you
you,
went the distance. That's the thing. Yes. So you didn't settle for what is easy. So you knew, or somehow you were in for the long run, and for no speculation, but also a talent, I would say, to combine analytical and qualitative, this intuitive ability, which
I
is
like
unique.
the analogy for someone who hasn't done this is, but plays an instrument. You play scales and arpeggios on a piano. Um, that's like learning the mathematics, but that's not the same thing as playing music. That
Exactly.
the theory construction and the synthesis comes in.
And that's the qualitative aspect. Yes.
But you can play as many scales as you like and not be a good musician. It's all, you know, making
Yes.
it.
And you are playing the scales of mathematics to reveal the beauty in neural networks and how the brain works, if I may continue the metaphor.
The harmonies of our mind.
Exactly.
That,
Wow. Wow. So now with this, I think I can move to ask you, what is adaptive resonance theory? Because harmony kind of resonates with that.
yeah, yeah,
And how does it fundamentally differ also from the deep learning models like those behind ChatGPT? And in general, the limitations of the current AI. Yes.
yeah.
So how does art address that?
Okay, so, as I had just remarked, what got me into the field was I was really interested in how learning occurs, and that expanded into an interest in how our brains self organize during both childhood development and adult learning. But a fascinating thing to me always was how can we learn quickly without forgetting what we just learned just as quickly? Or if we learn something new, why doesn't it overwrite the memories of what we earlier learned? So, in other words, we're very good at learning quickly without suffering from catastrophic forgetting. And I like saying we hereby, or our brains hereby, solve what I like to call the stability plasticity dilemma, which I'll say a little more about in a moment. But I introduced adaptive resonance theory, or ART, or ART, as you like, in 1976 to solve the problem of how we can learn quickly without suffering catastrophic forgetting. And it wasn't a leap for me to be interested in because, after all I'd ever done my whole life was learn in school. So learning was very important to me. And I like to say that art is currently the most advanced cognitive and neural theory that provides principled and unifying explanations of how we humans learn to, as we just summarized, attend, recognize, and predict objects and events in a rapidly changing world, because our world is always changing and filled with unexpected events. And one of the main facts of life is how do we do it? Um, and I could say that art succeeds in doing this in the sense that it explains orders of magnitude more psychological and neurobiological data than any other theory I'd ever heard of. Moreover, you might say, well, why should I believe this damn thing? Or who gives a damn? Well, already in 1980, in Psychological Review, which then and now is the leading theory journal in psychology, I was able to derive art from a thought experiment. You may remember that Einstein derived both special relativity theory and general relativity from thought experiments. Thought experiments show you understand something in a deep way because, starting with a few hypotheses we all know, you can tell a story based on those hypotheses. And at the end of the story, you've learned something that you never dreamed you'd understand, like gravity in the case of Einstein. But my thought experiment was about how any system can autonomously learn to correct predictive errors in a changing world that's filled with unexpected events. And just as in Einstein's thought experiment, or his thought experiments, the hypotheses from which I derived art in this way are just a few simple facts from daily experience that we all know. So you can't deny the hypotheses because everyone experiences, but when you put them together as conjoint constraints on evolution of a mind, you get a model like art. Moreover, nowhere in the thought experiment do you mention the words mind or brain. All you're talking about is environmental pressures on evolution. So art design principles and mechanisms are universal solutions to this learning problem. And again, I call it the stability plasticity dilemma because it asks how any system can learn quickly without experiencing catastrophic forgetting. Now, art is mainly a perceptual and cognitive theory, but we need our feelings and our values to guide our decisions throughout life. And so, as I was developing art, I was also developing a cognitive, emotional, motor model, um, how thoughts and feelings interact. I called it COGM, cognitive, emotional, motor. And I was able to finally derive COGM from thought experiment. And that led to a lot of explanations of data about how thinking and feeling interact. And let me just emphasize at this point that art and COGM together explained lots of data, psychological and neurobiological data about seeing, hearing, feeling, and knowing. And we did lots of quantitative computer simulations of the brain processes and the emergent properties of the behavioral experiences that come out. But after doing this for quite a while, I gradually realized that all of these parametric behavioral experience explanations, all these experiences are conscious and the humans having them. And I was hereby led to understand consciousness, I like to say through the back door, from analysis about how we learn quickly about a changing world. I like to say even more that I never tried to understand consciousness. You don't wake up in the morning and say, hey, today I'm going to understand consciousness. You know, it's therefore, I think, remarkable that art and COGM taken together have explained rigorously tons of data about how we consciously see, hear, feel, and know things about the world. Moreover, we don't just platonically contemplate the world. The models also explain how we use conscious states to plan and act to effectively realize valued goals. So there is a deep link between conscious mind and action, which really is a proposed mechanistic solution of the mind-body problem. How the mind and the body acts to realize the kinds of goals that enable us to survive in Darwinian selection. Now, conscious states all arise from resonances, and a resonance occurs when there's excitatory feedback signals between two or more brain regions. And the resonance occurs when these signals match well enough, top down and bottom up, to cause the selected cells that are matched to synchronize their firing and sustain it through the feedback loop long enough to trigger learning and with a consciousness. In other words, if we could not actively select the data that we're going to learn, we would experience catastrophic forgetting, and art solves the catastrophic forgetting problem by actively suppressing irrelevant cues and focusing attention on the critical feature patterns that predict behavioral success and that are embodied in the bottom-up adaptive filters and the top-down expectations. And it's because of this deep link between resonance and fast learning that I call the theory adaptive resonance theory. So to summarize this rather long discussion, I never try to understand consciousness just as I never thought when I began to understand psychological data about learning as a kid that I'd be forced to explain how interactions across multiple brain regions give rise to psychological functions. It
Yes.
basically came out of the wash, and I think, well, yeah, let me just leave it at that. It came out of the wash.
No, 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 because also my question was pretty all-encompassing. So thank you so much for answering in such a brief manner. But it was an enormous question, and I just want to underline, and this is a huge part of the value of your work. And this is that art is universal, yes, and it is done and built and inspired by proven phenomena. And and your models, like this cognitive emotional model, I mean, you solve the mind body problem in consciousness, which is a huge problem itself. And therefore, that is so important. And thank you for explaining to us. And I'd like to link this now, especially, with this catastrophic forgetting, of which the current technologies, which are, used in ChatGPT and so on and so forth, and which also, if I may, were rewarded with a Nobel Prize. They suffer from that, and you solve that problem. So I think this is to be underlined, and in particular, art also. Another huge merit is that it emphasizing explainable and interpretable artificial intelligence, and this is critical for building trust in AI systems. So the question is, if you want, because you didn't mention it, and if you want to contrast this with the black box nature of deep learning and the technologies which are used to
Well,
date.
I I tend to think that deep learning is the fad that swept AI and seemed to convince lots of people that deep learning is all you need to know to do serious AI. But as I said, I just turned 85, so I'm old enough to have seen a lot of fads come and go. I don't know how many of the listeners have ever heard of catastrophe theory of Rene Thom. Rene Thom was a truly great pure mathematician. I won't go into why he wanted to apply catastrophe theory to how um, couples get divorces. He really went too far. But it was supposed to save all computational science in the 60s and 70s, but it didn't, and you've never heard of it, most of you. So, but as to deep learning, if it's going to be used for applications, it should be benchmarked against all the other models that have successfully been used in that application, as adaptive resonance theory has against backpropagation, where, backpropagation is the learning algorithm that is used by deep learning. And it's been known, at least no later than 1988, that backpropagation is untrustworthy because it's not explainable, and it's unreliable because it can experience catastrophic forgetting. It should therefore never be used in any application with life or death consequences, such as a medical or financial decision. Um, because it's not explainable, if deep learning makes a good prediction, you don't know why. If deep learning makes a bad prediction, you don't know why. So, no life or death prediction should be made if you don't know why. But if you do use it and it makes a disruptive prediction that maybe cost someone their life, be prepared to be sued for everything that you're worth. When you're asked why you made the prediction that killed my loved one, and you have to say, I don't know why. As to catastrophic forgetting, deep learning also does very, very slow learning. As in backprop, you can only change the weights a little bit on every learning trial. That's why for a long time, backprop faded from view until you had vast databases on the internet and you could train it very, very slowly on millions of pictures of cats for weeks or months using floors filled with uber fast servers. And then after all that, um, you put in a picture of a cat, out comes cat, and everyone says, woo wee. Whereas art can learn in fast learning mode, the database on one learning trial. Gail Carpenter and I already showed that in 1987 with the Art 1 model, which has been cited thousands of times. So, but as to the catastrophic forgetting of learning the cat database, any time during its slow learning, perhaps after hundreds of thousands of learning trials already, part of its learned memory can collapse without warning. And then you have to start again. And no one tells you what happened when they were training it.
So
How
true.
long did it take? Many people are now coming down on it because of that. So, in particular, my 1988 article in the first issue of Neural Networks, the archival journal Neural Networks, which I founded, with 17 fundamental problems of backpropagation, including the above two, unexplainable and catastrophic forgetting, that adaptive resonance didn't have since I introduced it in 1976. To the best of my understanding, deep learning still has these problems. Um, it has no concept of goal, value, or meaning. As many of you know, it's an unstructured collection of millions of bits of text that have been scraped from the internet without permission, and for which they'll be getting more and more lawsuits in the near future. And added on that pile of textual fragment sentences or other documents, they have a probabilistic algorithm to choose the next several words or text to follow the last several words. And because of this, ChatGPT literally does not know what it's talking about. And its so called hallucinations are just mistakes. But people in OpenAI like to call them hallucinations as part of their marketing campaign that ChatGPT has some kind of intelligence. And it hallucinated something, but it doesn't have any kind of intelligence. All it can do is parrot combinations of the stolen fragments of information that are in its database. And I like getting a little poetic when I think about this, sort of improves my mood. Uh, Perhaps it's time to follow the advice of the great American poet Robert Frost in his famous road, The Road Not Taken. And I want to quote from it. Two roads diverged in a wood, and I took the one less traveled by, and that has made all the difference. Well, the one less traveled by the Nobel Committee has none of the problems of deep learning or ChatGPT. So,
Totally, totally. And if I may just complete this, is the AI alignment problem would not exist if we would have embraced art, because art is already aligned with biology, with humanity, with biological plausibility.
well, the
So
problem with those things that they have no intelligence, or,
exactly,
or
exactly.
that's the problem. They don't know what they're talking about, so they shouldn't be called any kind of intelligence.
So I'd like to move to this topic a bit, if you because your work is actually providing a way, and I would say a solution to this. In the last chapter of the book, you posit that there is a universal developmental code, and you alluded to this in what you said before, which underlines our conscious perceptual awareness, and which coheres in a sense of self, and which also enables the pursuit and accomplishment of value goals, and even predict the most valued outcome. And I've been cherry picking, I must admit, from your titanic work in support of our mission here at SingularityNet, which is to build beneficial artificial general intelligence. So, your opus magnum makes the case that the brain evolved in favor of good behavior. So, I'd like to center our further segment of the discussion on this discovery of yours and its implications in building a beneficial artificial intelligence and artificial general intelligence. So, you argue that brains are inherently biased towards good behavior. How come?
Okay, well, you also mentioned universal developmental code, so
Yes,
let's
totally.
unpack
Please, let's start with that.
a
Yes.
few things here. Um, so perhaps it's because our human brains and their precursors have ceaselessly interacted with the physical world throughout our evolution. Brain designs use principles that the physical world around us also obeys. That's why brains can understand the physical world. And these brain designs, I like to summarize as principles of uncertainty, complementarity, and resonance. Now, in the physical world, let's just look at quantum mechanics. Quantum mechanics built upon the complementarity principle of Niels Bohr, the uncertainty principle of Werner Heisenberg, and shows how resonances stabilize quantum states. Now, our brains build upon the complementarity of cortical processing streams. This is not something that I'll try to teach today, but like we have a what and where cortical stream. A what stream is a ventral stream for perception and cognition. A where stream is a dorsal stream for spatial representation and action. They obey computational laws like yin and yang laws. If you look at it, it's really quite beautiful. And so they probably evolved due to some kind of multi-stage symmetry breaking operation during evolution and morphogenesis. And the form and motion cortical streams are complementary. So we have complementarity of parallel cortical processing streams. We have the uncertainty of cortical computations. And that goes into like, how am I going to compute forms? Well, it takes multiple stages to hierarchically resolve these uncertainties. So that requires multiple processing stages, helps explain why there are so many processing stages in the human brain. For example, visual boundaries and surfaces are computationally complementary, yin yang, and you need multiple stages in order to be able to generate a representation of a surface that's complete, context sensitive, and stable enough to control actions like reaching and navigation. And then there's resonance, as exemplified by the fast learning without catastrophic forgetting of adaptive resonance theory. And along the way, one sees that conscious seeing is supported by what I call the surface shroud resonance. That's interacting with that completed surface. You focus spatial attention on it. That's called a shroud. And that spatial attention from the posterior parietal cortex also controls the action that comes from paying attention to a part of the surface. And recognition has a feature category resonance. That's just art. Art learns recognition categories that are based on distributed feature patterns. So taken together, these brain principles about complementarity, uncertainty, and resonance, a part of what's called universal developmental code, whereby our brains work like a universal self-organizing measurement device. We can measure, you know, photons, phonons, pressure, every sense that we can experience uh, in a coherent moment of conscious awareness. And we can do this just above the quantum level. Our retinas are sensitive to just a small number of photons. Our ears are tuned just above uh, going crazy due to uh, phonon noise. So it's this universality that enables our brain to unify information from all our external and internal senses into a coherent meaning of consciousness. Now,
Fascinating.
I could say more here, but um,
Yes, I would like you to say more, and I wanted to ask you also, to target your more to to my
well,
little agenda here.
see if I'm self-targeting, because
It is. Go ahead if you want to self-target, or if you want, I can ask you. So,
I've claimed that all conscious states are resonant states. Um, that emphasizes that all our conscious experiences of perceiving, feeling, and knowing use similar design principles and mechanisms, and assess a universal kind of computation that embodies all our mental faculties. And variations on shared designs in different parts of our brain generate resonances that support conscious perceptual awareness and cognitive knowledge about external sensory inputs, leading to conscious percepts of sights and sounds. Or we can have resonance about internal sensory inputs, like the cognitive emotional dynamics that lead to our consciously felt emotions. And each resonance supports an attentional focus upon perceptual or emotional representation that predict successfully expected outcomes. And they synchronize with related resonances that enable conscious recognition or knowing about perceptual or emotional events. So, by sharing this universal computational substrate, conscious perceptual, cognitive, and emotional representations can all resonate together so we can experience these coherent moments. And because they all resonate together and we solve the catastrophic forgetting problem, we can learn an ever expanding sense of self from a lifetime of learned experiences. Along the way, and this is very different from deep learning, by suppressing events that are predictively irrelevant using a top down art attentional matching that learns to focus attention on the critical features, as I mentioned earlier, that predict successful outcomes and that are embodied in all our learning, we learn the causes of events. All this stuff that's irrelevant is suppressed. And through the emotional interactions, we can gradually learn what our values are throughout our development through action and error, shaping us to get better at learning what we value and at carrying out the actions that realize our values. So this is an incremental process that critically depends on solving the stability plasticity dilemma. No model that has catastrophic forgetting can ever develop a sense of self, let alone any form of real predictive intelligence.
building on what you just on what you mentioned in answering the previous question is because so you make the case that although intelligence is the ability to accomplish complex goals, there is this morality embedded in the universal code which you explained to us. And I mean, you explained the universal code, but now I want to move to the morality issue, because this is achieved, as far as I understood reading through your work, by breaking the symmetry between positive and negative processes, with a built-in bias towards good, which implies that values are not purely relative. And this is so important, at least for us, because we are working on beneficial, yeah, artificial general intelligence. And in my opinion, I think all the problems in our current society is because we are not following those universal values, and because of the relative values, which are accumulation and consumption, which define success, and so on and so forth, that are leading us to disaster. So that's why this is so important to me to explain, if possible, this
Well, let's do
bias towards good, and
well,
that it's
yeah, let
universal.
do that. And now I'll make a meta statement first. This is like the gift that keeps on giving, because, of course, when I start my work, I never dreamed I'd have anything to say about such profound issues. And of course, what I say is just a drop in the bucket. Um, and a key point is that positive emotions facilitate positive, sustainable motivations and empathy. Remember now that we're talking about a special case of cognitive emotional interactions, which I discussed a little bit. And this can happen with positive emotion because there's a major approach avoidance dichotomy built into our brains for dealing with events that cause positive versus negative emotions. Notably, behaviors that cause positive emotions can directly support new behaviors that give it positive emotional incentive motivational support. But negative emotions tend to suppress ongoing behaviors or cause efforts to escape and avoid their source. So, for example, if an animal gets shocked, they can freeze. It's not leading to a sustained activity. At best, they'll try to escape the shock, avoid the shock. So the broken symmetry between positive and negative emotions is a foundation upon which moral and legal systems can build. Because they can build upon the foundation, because many of the acts that are considered immoral cause negative consequences like pain and fear, which can only lead to suppression or escape or avoidance. And well conceived laws often encourage behavior that reduce or eliminate negative consequences. So, such behaviors, like all effective escape and avoidance responses, may persist by building on the positive motions that may be amplified and additionally sustained by social acceptance. And it's through these social factors that we can get empathy in a context like watching the faces of others who are smiling and uh, um, that they're part of our capacity for social cognition. So watching a smiling face can activate our learned object category for the face, and with a cognitive emotional interaction into the amygdala and hypothalamus generate the same feeling of happiness that the other person is experiencing. This is often called mirror neurons, but it's really an application of cognitive emotional dynamics. Um,
And resonance is to me as a word reflects that. Yes, so I resonate
well, it's
empathically with another and so on. So
context of resonance is making sure that um, uh, by learning in a stable way that these activities are repeatable. In particular, learning that a smiling face uh, um, should make you feel happy and that it uh, represents happiness in the person you're observing. Uh, some people with autism, for example, can't do that. Um, the circuit's not working. Their arousal levels and other problems are not tuned quite the way other people's are. On the other hand, Asperger's uh, individuals can be incredibly creative and gifted in many ways. So it's not all a negative thing, it's just a different thing.
No, that's correct, and that's a good remark. And I will come back to that when I ask you about mental health, because, of course, in our community with artificial intelligence, we have a lot of creative people, and they exhibit many times such conditions. But I'd like to move, if I may, not necessarily away from this, but to go a bit into a bit of unknown, I would say. And what do you think? Like, do you believe it is possible to embed the brain's bias towards good behavior into the fabric of artificial intelligence? And how would your adaptive resonance theory guide such a process if you think it's possible?
Um, well, the neural network models I've already briefly summarized already include cognitive, emotional, motor circuits that learn to embed this bias. Because when you're interacting with the world, as I said, negative emotions and how they're linked to escape or avoidance, uh, suppress bad behaviors, and especially they can be triggered by external punishments or even by disapprobation from someone you love. Whereas positive emotions can sustain activities internally without external rewards for very long periods of time. Like if you ask someone who is a visual artist or other person who spends days, weeks, months quietly in their studio doing a big painting, what motivates them? Well, it's not someone coming by saying, oh, that's so pretty. These internal positive emotional can sustain behaviors for very long periods of time, as they do with a person like myself. When I first started publishing, there there were some people who said, "Oh, Grossberg used to be such a good student. He's gone crazy. What's wrong with him?" You know, and then the world caught up. Thank God.
Yes, yes, because so you didn't play by the tune of what others were saying, like the artist, right? So you went with creating real
That's
models.
why thought
Exactly,
experiments and that
exactly.
kind of logical evidence. If you've derived something from a thought experiment based on facts, we all say, yes, I know those facts. And someone says that's bullshit. Well, you know that they're wrong. Well, you don't have to think, am I crazy? You just know they're wrong. Um, I've had, unfortunately, experience that people would, you know, dislike my work and then they realize it's important. So then they try to steal it. you know,
Yes, totally, totally. I mean, this is
tell me if
too
my
prevalent human condition, I guess.
babies have other people's names on them. But, I'm not in this for priority. I'm in it for transcendence and the
Yes.
ecstasy that comes from it.
And yes, and I always say, if I find some of my work plagiarized, then I'm okay. This is good. It means it's good. Otherwise, they won't take it. So that's another way to look at it.
Well,
Yeah. What can I say? So the thing is, if we would embed and the world could do that, and I hope they will wake up, and we definitely at Singularity Net are on this quest. I mean, it would solve the catastrophic problem, the alignment problem in AI, because if the singularity is developed, I mean, if we get to the singularity, let's say, with this artificial general intelligence, super intelligence, without having those moral implicit deep code, uh, which are actually implicit in art, in the AI, then it will go really berserk if it follows how humanity is going today. So my question for you, now the next question is that again a bit speculative, and I apologize for that because I know your rigorous mind and work does not allow for much speculation. But I like just to ask, first of all, if you believe we can achieve a super intelligence that is ethically aligned with human values, and that if it could surpass even your or Einstein's intelligence in its capabilities.
well, I want to start by replacing weak deep learning and ChatGPT models with biological self-organizing models like ART-COGM and the like. Um, if you look at my webpage sites, sites.bu.edu/Steve G, you'll see 7 archival articles which together create a blueprint of an autonomous, adaptive, mobile agent that has, serious biological intelligence built into it. Um, and such models of biological intelligence are manifestly compatible with human intelligence because they're modeling human intelligence, and thus they can be used in a self-consistent way to complement and enhance human skills in situations where that kind of contribution is valued. So I do think, having uh, compact, ultra fast uh, models like the ones we've developed um, as a co-pilot, not to try to take away from the current use of that word for humans who want it. I think it won't be super intelligence, but it can be very helpful. For example, um, we do have Google, which is quite wonderful, I think. Um, but you could have search engines that had all sorts of information more about ourselves. One of the things I comment about in my 2021 book is, our societies that focused so much attention and wealth on enhancing the external world that we've really sort of neglected a lot the internal world. And uh, I hope that discoveries like those I and my colleagues have made can be helpful in giving more support and insight to people whose internal worlds need it. So,
Absolutely, absolutely. And I will come back to this.
so taken together, let me just say, I like calling all these models natural intelligence or NI to distinguish it from the word AI when that word doesn't have any intelligence linked to it. And you may know that one of my early books is called Neural Networks and Natural Intelligence. It's been what I've been trying to do my whole life. So,
Totally, totally. And I'm just thinking before I move to the more, the deeper and broader implication of your work, I'd like to stay with this, like, let's say, more focus on technology and development of technology. And I wanted to ask, because I believe your work is definitely very important for that, and at least to reveal, yeah, eventual dangers or opportunities. What do you think about the rise of brain-computer interfaces with Neuralink and all these things that are happening now? Do you see any ethical challenges or opportunities that your theories would present for, enabling us to look inwards as well, versus only using outward models for improving ourselves, if I get?
well, let me start by saying I think there's a lot of brilliant work being done already in developing brain computer interfaces, and some of which have, been very helpful, and especially with people who are almost totally paralyzed to communicate and move. Um, but in general, I like to say, when you talk about me not speculating, I speculate a lot, but my speculations remain private until I have some evidence of them. But I do like to say that I couldn't predict the present. Could you?
No, I
So,
created.
I do hesitate to try to predict the future. But on the other hand, I do know that we're designed to adapt to unexpected environmental contingencies. And I believe that if we design a brain computer interface that includes some of the benefits of the insights of biological neural networks, then we can interact seamlessly with this interface using shared cognitive, perceptual, and value understandings. So I think, the more you bring to what the interface can do, the better. Um, if it's only if it's being used to help people who are almost totally paralyzed to use, eye pointing, for example, to control, you know, artificial limbs. Well, that's the story. That's already a big enough challenge for the person who has to deal with it. It would depend, but there could be opportunities where more information about how to, for example, I spent with many very smart students and postdocs a lot of years developing a general purpose vision system that can, you know, see depth, shading, texture, color, brightness, uh, and and embody them in 3D surface representations. Uh, if one put the investment into having a general purpose vision front end um, for people who need that help, who are, have low sight and they want to stay as mobile as they can in the world and get it into a compact BLSI form, for example, that could change many lives. But we're talking about two very big problems here. The first problem is, um, uh, getting the resources together so people will try to build a software implementation of the whole thing at once. I had to do it with my students, trying to explain different kinds of databases and validate them in separate articles. and then PhD students and postdocs want to get the hell out. So it's not like you have a, a big company that can devote 5 or 10 years to systematically doing the whole system. And then there's the hardware problem if you want to miniaturize it, which is, or, if you had the vision sensor going into a pretty small supercomputer that's able to process the visual signals, and that can be ported with the individual who are moving, then you don't need VLSI, which is much harder to do VLSI of a vision system. Carbamide and photographine did a simple retina, but the vision system, that's just the beginning. The retina, you know, it's all the visual cortex we have to worry about. But, doing the software for a complete vision system and having a portable sensor on the head and having a not too heavy supercomputer, let's say on a backpack that could process those signals and maybe give feedback. Maybe it could be verbal feedback. What's in the scene? Of course, now they do have, quite helpful things where, based on usual emotion, they'll put a little red box around things and, help people not to collide. But in fact, if you look at uh, my papers with Andrew Browning on my webpage, we showed how, more than that, how you could have driving in a cluttered street scene. How that could be implemented, but that would take a lot of work. Just look at the problems Tesla had with whatever it's doing and all the crashes and deaths it's caused. But they don't really have, I don't think, anything like a vision system guiding the car.
You alluded somehow, to let's say cyborgs, human enhanced by technology, and this is human computer interfaces are part of that. Brain computer interfaces are part of that. Because in 78, you demonstrated morphogenesis by investigating how Hydra regenerates a missing head and how slime molds aggregate in search for food. And Michael experiments, as I mentioned, they are geared to demonstrate what he calls cognition as a cellular level. But I think you are the real pioneer of that field. So the question is, though, because I don't think you called it cognition, I don't know, but maybe in the last chapter of your magnum opus, you are alluding to that it is a sort of cognition, if I read it correctly. So the question is if you agree with Michael Levin that to call the phenomena that enable morphogenesis as cognition. Is that correct? And what do you have to say about that?
First, in my chapter 17 of my book, I discuss slime mode aggregation. I first say in a paper I wrote in 78 called Communication, Memory, and Development. And there, what fascinated me about a number of the morphogenetic um, events, including slime mold aggregation, it's a kind of on-center off surround recurrent network with mobile units. So that doesn't need, cognition, but many morphogenetic processes. And now let's not necessarily look at slime mold. Let's look at changing a blastula into a gastrula gut. They obey mathematical laws like a simple form of adaptive resonance. If you read chapter 17 in my book, you'll see, that directed growth is and stabilizing at another side of the blastula to start making the gastrula.
Exactly.
monologues.
And I would recommend, if you don't mind, that people can start by reading that chapter, because
Yeah, well,
it makes reference to all your work.
the
That chapter is
question,
amazing.
I wrote it so all the chapters are readable independently, but I do recommend maybe you read the preface and chapter one, which is an introduction that gives an overview, but then the chapters you can read in any order. Um, but so gastrulation is, as I indicate in chapter 17, a simple kind of adaptive resonance. And I like saying it illustrates this universal developmental code because you're having adaptive resonances in, these very primitive structures. And then we have it in cortex. But humans have enough neocortex for adaptive resonances to support cognition. But single celled and very small networks undergoing morphogenesis don't. So if I had to interpret what he says, I'd say that yes, there is a universal developmental code, but cognition required a lot of neocortex, and that you know chimpanzees and some monkeys and a lot of animals, I believe, are conscious and they clearly have feelings and can plan, and some of them do many things that we can't do, like they can have incredible sense of smell. But when it comes to cognition, our prefrontal cortices and our temporal lobes really expanded a great deal beyond other species.
Yes, and I think, this is kind of tied, as much as I very much respect Michael Levin's work, it's tied a bit to the degree of speculation, yes, which comes with
Well,
consciousness, cognition. Now the cells have cognition.
what his motive was. Maybe it was to attract attention of a new. I have no idea, but there's clearly no cognition there, and a lot of the mass action effects can occur due to more primitive things, um, like on center off surround approach, attractive repulsive effects, like in the slime mold, and like in gastrulation, there is a kind of adaptive resonance going on, but whereas that principle may be conserved through phylogeny, cognition is not.
Exactly. So we have to really call these phenomena what they are, because I mean, he is saying there's mind everywhere in the atoms, in the cells, and everywhere.
Well,
And,
the first question to ask is how do you define mind?
exactly.
I mean, it. I you have to define mind.
I avoided to ask you what is consciousness, what is mind, because these are,
Well, but
it can be 3 hours
I
answers.
defined what I mean by consciousness. And it's there are 6 different kinds of adaptive resonances that support different kinds of conscious awareness in different parts of our brains to carry out different functions for which have they been validated by explaining much more psychological and neurobiological data than any other theory. So, for example, a feature category resonance like art, the basic art classifier theory, that supports conscious recognition, but a surface shroud resonance supports conscious seeing, which is not the same thing as conscious recognition. And if you have certain ablations, like if we talk about mental disorders, someone can see and reach for something without knowing what it is, cause the ablation caused an agnosia in their what stream, in their category level. So seeing and knowing are different. they're often linked, and when they resonate together, as will happen when we see someone we know, we can say, oh, that's Bobby or that's Sally. And if they resonate, if the feature category resonance and the surface shroud resonance and the stream shroud resonance and the cognitive emotional resonance, if they all resonate together, we can start to appreciate a little bit of music. But then you need an item list resonance to be able to appreciate musical phrasing. So all these resonances would be synchronizing in complex ways during a musical experience. And so they're not the same, um, even though they synchronize a lot. So, um,
So it's not like one resonance. There's several, like a symphony of them,
yeah,
and then how they
you can
interplay.
see by if you have a brain lesion of one kind or another, you lose that resonance and you can't do something anymore.
And this leads us naturally to the mental health question. Right on. So because your work sheds light on mental disorders like anxiety, depression, I don't know about you mentioned Asperger's and the others. I don't know if you also decoded those ones, but let us know. How does your work shed light on that?
Well, I like to say, excuse me, I never tried to study mental disorders, just like I never tried to understand consciousness. I was driven into both through the back door. You don't wake up one day and say, oh, today I'm going to understand schizophrenia. Oh, I'm going to understand Alzheimer's. Yeah, good luck. Um, but what I did do, there was a ton of data about normal or typical behaviors that's far more abundant, parametric, and organized than data about mental disorders, which isn't surprising because with mental disorders, they're clinical patients. You try to take care of them. You don't often try to do parametric studies on them in a hospital setting. So I spent a lot of effort, as our chat has indicated, trying to understand the brain dynamics that give rise to normal behaviors. But at a certain point in model development, I then noticed that in response to particular imbalances or other breakdowns in model mechanisms, formal syndromes of behavioral symptoms of various mental disorders started emerging, falling out of the wash. And, that's because there's this yin yang balance between these things. Everything is beautifully balanced. Well, if the balance gets a little screwed up, suddenly you're a little crazy, maybe. Um, so the symptoms are emergent behavioral properties, remember, of multiple brain mechanisms interacting together. And that's why I was able to study them, because I understood how these emergent properties come out of the models. Purely experimental methods can't directly study emergent properties, and so they can't clearly describe the link between the brain dynamics and the emergent behavioral properties of either typical or normal behavior or mentally disordered behavior. So by noticing this kind of breakdown versus that kind of breakdown, I was able to write articles that I haven't been stoned to death for doing so, about Alzheimer's disease, autism, medial temporal amnesia, schizophrenia, post-traumatic stress disorder, attention deficit hyperactivity disorder, visual and auditory agnosia and neglect, some problems with slow wave sleep. I also showed why people with Alzheimer's and autism often have problems with slow wave sleep. And in fact, I've been doing this for a long time. I was invited to the first International Congress on Schizophrenia Research, 30 or 40 years ago, to give an opening keynote on my models, trying to explain how schizophrenic symptoms arise. But a key point in my contribution, I don't presume to replace clinical interventions and therapies, but the insight I give is by studying with the normal or typical behavior and then explaining how particular breakdowns of mechanisms generate the emergent properties that show themselves in behavioral symptoms of mental disorders, you can get a deeper mechanistic insight into how a lesion in the brain, which is on one level, it's on a level of anatomy, can be rationally linked to behavioral symptoms, which is far more abstract and holistic. And hopefully that can help point people to more efficient therapies. But I'm not a neuropharmacologist and a clinical um, uh, neurologist, so I'm not the guy who would do that.
No, but I mean, we started with you at 17 as studying psychology, and of course, that gave
Well,
you a
well,
lot of
you know,
insight, and it's your passion. So,
um, with that foundation
yes.
uh, of all those discoveries I've been able to make with a lot of over 100 gifted people, that really gives us a lot of the biological bases of the human condition. Um, and that's how I was able to talk, at least heuristically, in chapter 17 of my book, about issues like creativity, morality, biological bases of religion. I already mentioned a little about causality. Also, I talk a little about superstitious, irrational, self defeating, even self punitive behaviors and how they can arise as part of the human condition. You know, whether light, there will always be shadow. And these shadows um, arise when change the format in which the light is received. And, things like um, uh, conspiracy theories, how they can persist despite disconfirming evidence in certain social environments, as we see so tragically today, even though you might view having these conspiracy theories as a form of self-punitive behavior, because the person who is, obsessed with the conspiracy and all the hate, it certainly isn't the kind of emotions, the positive emotions that can help you lead a fulfilled life, that actively interferes with the positive emotional opportunities. And whereas there are social explanations, economic explanations of how this has happened to so many people, and hopefully the government can assuage those problems through economic interventions, et cetera, um, doesn't make it any less tragic.
Looks like humanity is on a course of self-destruction. Yes, so we exhibit, and these conspiracy theories are also like symptoms of a self-terminating society, I would call it. So what is the drive behind that? Would your work shed any light on that? And then of course
Drive
intervention can
behind,
be done.
The drive behind what?
Behind these self-destructive tendencies with to delve into conspiracy theories, like self-punitive, self-destructive behaviors.
Well, you know, I
Yeah.
I think it would be best to read chapter 17 for what I can say.
That's why it's my
But,
favorite.
but a key point behind all those explanations is that our emotions, not only our emotions, our whole brain is organized in opponent processes. But opponent processes include opponent motions like fear versus relief, or hunger versus satiety, or sexual arousal versus sexual satisfaction. So everything has these opponent emotions, and that's sort of like the light shadow issue. And it's not only our emotions. For example, we have opponent colors. If you look at something red for a long time, look at a white piece of paper, you'll see a green after effect. Um, if you look at water flowing down for a long time, look at a white blank page, you'll see a motion after effect of apparent motion moving up. So all parts of our brains are organized in these opponents. And, if they get out of balance based on what's called partial reinforcement acquisition effect in particular, bad things can happen. So what is partial reinforcement acquisition effect? First, it's necessary to survive. Um, we couldn't survive if we needed to be rewarded for everything that we did, for every action. First, your parents are too busy to reward you as a little kid for everything you do. They have to go to work. They have to prepare dinner. They can't be rewarding you day and night. So the partial reinforcement acquisition effect explains how an interaction between the reward itself and our expectations of reward can enable us to get by with intermittent rewards in life. So that's why top-down expectations are so important. And when you muck up people's expectations, you can also muck up the balance between the expectation of reward versus punishment. And I give examples in the book about, I think it's chapter 13 and maybe 17 too, and these how partial reward works. And all of the human condition has a bright side and a dark side. For example, gambling behavior. You might start by gambling in the broadest sense. Someone gives you a reward for something. Let's take a love affair. Okay, take a love affair.
That is a gambling thing, definitely.
Naturally, it's so rewarding. You love each other dearly. You're rewarding each other in every possible way. But then your lover gets tired of it. And so they start gradually pulling away. And you're getting less and less rewards. And, you know, you you try to call them. And if they answer the phone, you feel so great that you still keep the expectation that somehow your level's alive. So, it's a double-edged sword. It helps you plan and carry out meaningful activities to live with partial reward, but it can also get you into deep trouble when it gets into the wrong environment. And conspiracy theories arise in such an environment. And then they can persist. Especially a dear leader every once in a while says how much he loves you and gives you absolutely nothing but that token of love, just like the phone call with someone who doesn't give a damn about you anymore.
So true, and it is so reflective of human condition. All what you said here, that I mean, it almost moves me to tears because it is so true. And this asymmetry which we referred to in the beginning, between good and bad, and which you mentioned here, also. As these opponent processes, I mean, if they are out of balance, if they are, let's say, out of balance a bit towards good, that's good, and this is what we want. But if they are, and it seems like in our day to day they are more and more balanced towards the self-destructive thing, and how do we restore that is a big quest, at least a big quest, which I have personally, as well as we here at Singularity Net. So I'd like to ask you, and I do not know if this is related to this asymmetry, but this creativity and flow, yeah, so this kind of processes which Mihaly explored in his book, like states of flow. Does your work explain any of these kind of states, how they
Well, well,
arise?
I actually didn't know his work before.
Oh.
So, of course, when in doubt, Google.
Or chat GPT, maybe.
So I Googled, and what I Googled, I think the answer is probably yes, that that I supply a kind of principle mechanistic understanding, whereas he's just not just he's describing stuff
He
like,
is speculating,
yeah,
yes.
he identified, let me read, 9 dimensions of flow, whatever the hell that is: challenge, skill, balance, action, awareness, merging, clear goals, unambiguous feedback, intense concentration, control over the task at hand, loss of self consciousness, transformation of time, and autotelic experience. And I think all of these can be explained using available models, neural models.
Correct.
So I think it's useful to have constructive frameworks of many kinds, and if it can help people to be more fulfilled and happier and more productive, uh, I'm all for it. Uh,
Amazing. And this is, of course, hinting to future research, yes, people to use your
well,
work.
I'm not sure that implicit in his 9 dimensions of flow is enough there to use it to inspire future research. I mean, to really do profound research on mind and or brain, you need a big enough database. And like in psychology, um, like American learning theory, the vast databases about how we learn. Um, I haven't worked in areas where there's very, very little data, because a good theorist, a good thinker can give 20, 30 explanations of a single fact. You need scores or hundreds of facts uh, that all constrain your thinking before you might have a single worthwhile idea. So if there aren't enough data, for me anyway, I don't think you could do meaningful theoretical science. Um, and, in no sense is the concept of flow data. It does, the flow dimensions don't map onto um, natural categories of competences of brain and mind, um, like intense concentration. There isn't a field of intense concentration, but you might ask, well, how do we learn how to focus attention? But to do that, you have to ask, well, how do we learn what we want to attend to? And pretty soon you're in art and cog-m.
And
But,
relevance, yes,
you
what
know,
you studied,
in,
yes.
in such models, but not from the flow names themselves. Yeah, maybe
Correct.
how do we keep going?
And speaking of this, speculative angle versus rigorous data-based approaches, which characterize all your Titanic work, I wanted, to ask if you have any opinion about, and if you even know about this Donald Hoffman, The Case Against Reality book, and of course his work. He's a professor at University of California at Irvine, which argues that we perceive a screen and not reality. It's like we have goggles, and that we see like the screen, but not the electrons behind the computer screen and what they
Well,
do.
of
Any?
course,
Okay.
our brains actively construct percepts and concepts. I don't know a single psychologist, experimental psychologist, or neuroscientist who doesn't think that. When talk about a screen, where's the screen? Is it the retina? The retina does the most primitive kinds of processes necessary, but you then go through lateral geniculate and up to cortical area V1, V2, V3A, V4, infratemporal cortex posterior and anterior. All of these things are actively constructing how we perceive and understand the world. There's no simple screen. So my work goes way beyond such metaphors. I do evaluate all mind-brain theories according to how much psychological and neurobiological data they can explain and predict in a principled and unifying way. And I haven't seen much of that in Hoffman's work, but I stopped reading it a long time ago because at the time anyway, it didn't teach me something I didn't already know on a much deeper level. I should emphasize, though, I'm a glass half full guy. If there's something there that I feel, oh wow, that's really great. That's nice to know. I'm grateful. I don't want to feel I have to discover everything. I want other people to increase their knowledge, and many gifted people do and have. But I don't think the notion of a screen adds anything. I think it distracts from what we already know about how we construct reality.
Totally. And with regard to this, yes, let's say more speculative works, I think, some of them, as you mentioned, they are important. They point to things which we have to explain and discover in much deeper ways, which is actually your approach. Coming back to this point that values are not relative, that they are universal. Lately, like a series of books came out from a pretty important scientist like Stuart Kaufman, who is a MacArthur Fellow, and he wrote At Home in the Universe and so on and so forth. He wrote the Reinventing the Sacred, which actually posits the same, that values are universal. Then more recently, NASA.
Well,
There is
let me talk about Stu.
okay. He's a friend of mine.
I met Stu Kaufman when we were 17 on the first night of a camping trip with Dartmouth freshmen. That's even before I took introductory psychology. And we talked philosophy on a straw mat through the light the night everyone said, shut the hell up there. And now he calls me Brother Steve. I call him Brother Stu. So we're dear friends.
Well, I didn't know you met him
So,
so early, and
well,
I yes, go ahead.
yeah, I've known him longer than I've done science.
Wow, I envy you for that. I mean, both of you.
Well,
I wish I would have met
we
you.
don't see each other that often, but occasionally now we'll do Zoom.
Oh,
Uh, and I'm very fond
I
of.
want to be a fly on the wall, an electron on the Zoom.
Well, what we talk about, we're not having scientific, philosophical debates at our advanced age. We're asking, how's your hip doing? Stuff like that.
So this is related, of course, yeah, with these universal values. But you also make the case in the book that we are tilted towards goodness because of this asymmetry, right? And
Well,
uh,
I think that is a biological substrate,
yes,
which helps to maintain it. But then, based on that, there are so many social developments over history in creating communities that were able to sustain themselves and flourish by emphasizing that biological substrate. So there's a huge amount of social development, social cognition, history, uh, because the opposite, as I point out, suppresses behavior and leads to escape or avoidance. And you can't build a civilization on that substrate.
so
So,
it was a natural selection somehow. I mean, those survived. Yeah,
so
who?
yeah, so that I think the asymmetry creates the seed for a huge amount of social amplification. And I've only written one article on social cognition. It's the huge field that I hope other people will try to understand. Even it's a very, very challenging to explain how we do joint attention, like how when you're a kid, when your mom uh, points in a certain direction, how you even know how to look at your mom, recognize your mom, feel things about your mom, notice the direction she's looking, and use that to look in that direction. That already uses a huge amount of brain. So, thinking about that, all the other kinds of social cognitive skills we have to learn, there's still a lot of work to be done to understand them deeply. My hope is that, well, no, I mean, the people who, that's the tragedy, the people who could most benefit from it in terms of turning their lives around are already victims of relentless propaganda. So,
Unfortunately, it's so true, so true. So and that that's still the
yeah,
open question of our world, as you say. I mean, how do we stop that? But I'd like to stick to our topic today, and I of course hope to have you in the future for the other discussion as well. It's if we are. I'd like to move towards the your legacy and to start with, if the readers take away one key insight, but I'm sure there will not be only one, but I mean a few key insights or one
well,
from conscious mind resonant brain. So what would
well,
you
I would
suggest?
say we're conscious because we can learn without catastrophic forgetting. I think that's important. It's a chain of reasoning. Moreover, when you use the word conscious, keep in mind there are at least 6 different kinds of conscious awareness that have been functionally and mechanistically explained and that help to explain huge amounts of mind brain data. So, and then on a meta level, never listen to anyone who says we don't understand how the brain works. Understanding anything in science is always incomplete, but we understand a lot of data about how our brains make our conscious and unconscious minds in both healthy, typical individuals and clinical patients. So, as they say in the old country, we've come a long way, baby. Um, I've worked really hard, like in my magnum opus. I don't know if everyone has seen it, but here's my baby, conscious mind, resonant brain, how each brain makes mind. If you're wondering what this is around the brain, the red and the blue, if you look at it, depending on your own brain, either the red will spill out into concentric or diagonal uh, uh, neon color, or the blue will. It's called neon color spreading. I fell in love with it at an early age. And it's an example of the fact that our minds understand the world through emergent processes. Seeing neon is an emergent process in our mind. And you need to understand a lot about how our brains see to explain visual illusions. In fact, you might say, why do we see visual illusions since Darwinian selection seemed to design us to adapt well to the world? Well, it turns out that Darwinian selection works most of the time, but there are contexts in which it doesn't work so well. Visual illusions um, are one case where we're not seeing what's actually there. Or self-punitive behaviors are another case where things aren't working so well. So we are designed to adapt to a changing world most of the time, but there are uh, some situations where we won't do it so well. For example, irrational decision making under risk, um, which Kahneman and Tversky got the Nobel Prize for showing how we make risky decisions. Um, and my student Gutowski and I explained how that happens based on basic cognitive emotional dynamics. So the cognitive emotional dynamics are designed to help us adapt, but it doesn't prevent us from making irrational decisions in certain contexts. And that's why parents very rightly are worried when their kids go into certain situations with people who are bad influences, because those bad influences can break through our adaptive mechanisms and get good kids to do bad things.
And social media is one. Let me brag that I
Social
also have
media,
your book on Kindle, though, because I that's how I
social
read.
media
So
is one. Uh,
uh, it's
yeah,
amazing.
yeah,
So-
social media is scary, powerful. It's done a lot of damage. And X today, he should be ashamed.
oh,
And
I
so
cannot be there. I cannot stay even 1 second on X. I mean, it's just
I've
I
never,
don't understand it.
I've
Yeah.
never joined any of them. I am
No.
on LinkedIn. Of course, LinkedIn is more scholarly.
And we know who the people. I only connect to people who show their work there, and I know
Yeah,
who
it's
they
all
are.
about discussing
Yes,
reasonable issues. Yes, so
exactly.
let's see. Oh, you wanted to ask me?
I want to ask you about,
Well,
the most exciting areas in neuroscience that you are currently
well,
exploring.
but you were sort of, I'll narrow it to like what I'm doing. I mean, and I wanted to mention that I have a new book that's in press
Exactly, yeah.
with Oxford University Press. I hope it'll be out within a few months. I don't
Oh,
know.
wow. It's already cooked.
Oh,
Okay.
yeah, I have a contract. I gave it to them many months ago. But they move ahead in a stately fashion, shall we say. It's called Your Creative Brain and AI. how we learn and consciously experience art, music, and meaning, keeping in mind that ChatGPT doesn't know what it's talking about. Part of what I explain in the book is how we do learn to associate with our language utterances perceptual and affective meanings. Satisfying is that after working so hard for so long on sort of foundational mind brain processes, it has been able to clarify for me how visual artists make their art and how we consciously experience it, and similarly, how we can learn and uh, consciously experience and enjoy music, et cetera, et cetera. So, so that's been very satisfying. But in all these cases, I just touched it's just a drop in the bucket. Other people who are interested, I hope, will keep keep developing these insights for art and music are unbounded, and I hope other people get interested.
Well, so, and this kind of, leads me, I wanted it to be the last question. It may not be the last question, but because you mentioned the title of your book and all this about meaning and being related to creativity and this freedom to express ourselves and manifest that creativity, what to you would be then the meaning of life?
I mean, the meaning of my life, well, I am blessed to have been with the love of my life for over a half century. I'm blessed to have a daughter and two grandchildren who I adore living 20 minutes away. I'm blessed to have wonderful friends and colleagues. And mostly, since I spend most of my time by myself, as every thinker does, I'm blessed to have my creative gift, which has been with me for over 67 years and which has made um, my my life very meaningful. I'm not saying that the meaning of life is my life feeling meaningful, but my life has meaning to me because of all the love in it and because I have a life's work that I love to do. So it's all about love, broadly understood. So I don't think I'm the first person to have noted in a reply that the meaning of life is love.
But the answer, it shows exactly what, as you point to, that it is kind of universal, right? I mean, love, yes, and love and related to family, as you mentioned,
I
and
feel very lucky that
yes.
I've been able to do this. I mean, there were many years of struggle, and but I mean, I'm a great believer in the law of unexpected consequences. If I can take the liberty of telling you one, my wife Gail and I um, um, uh, were going to the Cape to visit friends, Cape Cod. I don't know if you know where that is. It's in Massachusetts, and there was the annual meeting of the Society of Mathematical Psychology, of which I'm a early member, and I was invited to give a talk. I figured, okay, I'll go. We'll go to Brown, where the meeting was held, and it's right on the way to the Cape. Anyway, at that time, I was a young assistant professor at MIT, and I gave my talk, and a man came up to me afterwards. His name is Henry Hamburger, And he said, wow, that was really interesting. I assume you have big grants to do this. And I say, not at all. I have 2 months of summer salary as part of a group grant with my colleagues in the MIT Applied Math Department. And then he did the most amazing thing. He got in touch with program managers in all of the funding agencies in Washington, National Science Foundation, National Institute of Health, Army, Navy, Air Force, DARPA. You go, all of them. He invited them to the National Science Foundation to hear me talk for a day. No one made him do that. That was pure generosity. And because of that, I started to get big grants. And because of that, I was able to found a center and a department and institutes. Of course, no one was going to keep pumping money into my colleagues. I mean, we had to justify it. Of course, program managers answer to directors and directors answer to Congress. So we had to work like dogs, but we were given a chance. And there were people in life who were just good people, generous people, and people like that who I've been blessed to have my life enhanced by. I try to do the same for everyone who's crossed my path, if I have any way to help them. So, this is part of enhancing positivity,
Which proves that, yes, this asymmetry towards goodness actually
And
works.
it comes back to reward you in so many ways. For example, just last week, one of my PhD students, who's now a professor in Taiwan, and his wife and kids were visiting Boston, and he said, we'd like to have lunch with you. I mean, so one of my intellectual children and his family wanted to see me again. Well, that's lovely. And so that's happened a lot to me. So I've done my best to support them through their lives, and they've made me feel valued.
And which points to the fact that living a legacy is also part of what gives meaning to life. And it also leads me now, speaking of legacy, to the question about the advice for young scientists. Yes, so it's like, what would you tell aspiring researchers passionate about understanding the brain, consciousness? What would you tell them? What path to follow?
Well, you find facts or phenomena that you passionately want to understand, for whatever personal reason. No one can predict for you what you're going to be passionate about, if it's going to be in science at all, which it may not be. And then do whatever it's necessary to understand it in a principled way so that you never hit a brick wall. That doesn't mean you'll be a theorist or an experimentalist. But if you're going to have any calling in life, you should, I think, dive in and take whatever risks are necessary to fulfill that passion. Whether, you're going to be a great chef or a great astronaut or, commit yourself to it and do the work, do the hard work.
And that's what I used to tell my students as well, because they try to cut corners, and I say I'm not here for instant gratification. I'm here for the long run. So you really have to,
But
to
that's the
know to put the
tragedy.
work.
That's the
Yes.
tragedy of ChatGPT,
Yes.
because education is supposed to be teaching you how to think for yourself, how to make informed decisions, how to live your life productively. And if you're not going to get anything from education because you're always copying stolen sentences from an algorithm that doesn't know what it's talking about, you're selling yourself short. It's a tender trap. Once you're in it, you might not get out of it. And keep in mind the years when you're given opportunities, in particular as a student, those are precious. That you're not sent to work a backbreaking job in a factory when you're 10.
Because you mentioned this, I think that's something, a note on which it's good to end our discussion with this. I would call it warning, but awareness that there is a big danger with ChatGPT and this kind of course, AIs, that we will atrophy the ability to think critically. That this muscle we have to cultivate, because it is this that is giving us motivation, meaning to our life.
What worries me is the signal to noise ratio is very low now. And to understand the contributions I and people like me have made to understanding artificial intelligence, that requires real effort, real commitment. And with all this, you know, you can get something for free.
Temptations.
Yeah, they're just making a lot of noise.
Yes.
Makes me sad, but
Yes.
there's
Me too.
always someone out to make a quick buck.
Yes, and I would like, of course, on this note, yes, you are invited. Please, it's a commitment, at least on my end, that as soon as your book is out, your new book, which is now in print, I'd like to have you back to discuss this in more depth, in more detail.
I'm also writing another book.
Wow. Yeah.
I have another book planned after that. So if I can last as long as my mom, maybe I'll finish them all.
No excuses for anyone then to tell us that it's hard to write books and it's hard to do this and that. You are such an inspiration, Stephen. Thank
It
you
is
so
it
much.
is hard.
It is.
It's hard. But if you love the work, it's worth it.
Exactly. Discipline. And that is, again, a thing which is kind of related. I heard this from someone else saying that love involves a lot of sacrifice, and love for your work, definitely as well. Yes. So,
You're lucky enough to survive. And I realize I knew a lot of very gifted young people who wanted to do this or that, and they weren't lucky enough. So
it's an obligation if we are lucky enough
was
to be able
lucky.
to
I
pursue.
worked like a dog to try to justify my good luck.
Yes,
You never
yes.
should take it for granted. It can change in an instant.
So true. And that is, again, a very good advice for young people. Yes, do not take your good luck for granted. There's an obligation, yeah, that comes with
Another
it.
thing is, over the years, I cut people out from my life who were negative, people who really care only about their own narrow self-interest. There are
Yes.
so many good
The
people.
toxic people, yes.
Yeah, avoid the toxic people. Anyway, thank you so much for taking the time to have
Oh
this
no,
chat.
thank you. I do not know how to thank you for this fascinating conversation.